Okay, I'm going to start out this video with a joke. And I don't normally tell jokes because I'm not very good at it, but here we go. What does the 0 say to the 8? Nice belt. Anyway, this is the third video in the log and exponents section. You can see here the objectives. These are the things we're going to do. So now that you're controlling yourself after laughing so hard, we're going to move on. One important thing to remember about logs, and one that will help you when you're dealing with them, is to remember that a log is equal to an exponent. A log is an exponent. It's a way to write exponentials in a different way. It's also a way that's used to handle very large numbers, and so that's why logarithms were created. So the definition you can see right here, f of x is a to the x. This is an exponential function. The inverse is the log to the base a, the same base of x. So if you write the log as log to the base a of x, then that would be equal to the base. This is the base, this is an exponent, and this is the value. So a to the y equals x using that. The log is always equal to an exponent. Here's another example. If y is equal to 3 to the x, then you could write the log, right? The exponent, x, same exponent, is equal to the log with the same base, 3, of the value. Now sometimes they do a pattern, but to me, if you can keep the base straight and the exponent, there's only one other thing left, and it goes here. So let's do a few examples. 7 to the third equals 343. That's a true statement. So let's just write it in log form. Well, first thing you ask yourself is, what is the exponent? So the exponent is equal to the log to the base, which is 7, of 343. Those are equivalent statements. Same thing here, my favorite, 2 to the 5th is 32. The exponent, 5, is equal to the log base 2 of 32. They mean the same thing. 5 is the exponent. 2 to the 5th equals 32. Now, common log is base 10. On your calculator, that's the LOG button. Base 10 is not written. If it was, you'd put a 10 there for the base. So if I want to write the log to the 8, remember that this is the exponent. 10 is the base. So base to an exponent equals a value. And if I were solving that, since this has 3 zeros, the exponent is 3. Natural log is base E, and it also is not written, but it is a button that's on the button that's on your calculator refers to the natural log, base E. So once again, you start with the base is E, the exponent is x, equals 5. And that one's not as easily able to solve, so you would have to use a calculator, but that's how you set it up. Here are some special cases. In fact, I probably should have written that on here. Special cases that you can come across. If I rewrite this first one up here, the exponent, the base is 8 to the x power equals 1. Well, x, the only way you can get that equal to 1 is if x is equal to 0. Anything to the 0 power is equal to 1. All right? So same here, if I have base 10, this is 10 to the x equals 1, so this is also going to be 0. So I'm going to change that out and put 0. All right, same deal here, natural log to the base e of 1, e to what power equals 1 is 0. All right, now this one is a little bit different because the base and the value are the same. So if you were writing that as an exponent, it would say 8 to the x equals 8. Well, obviously, the exponent is going to have to be 1. So if these are the same, this is just going to be equal to 1. So obviously, this one's going to be equal to 1. Now, this looks almost the same. It's like a one-to-one property. If you have 8 to the log base 8, or the same power, it's just going to be equal to the value that's right here. They almost cancel each other out. It's the same thing here. The log to the base 8 of 8 is just 1, so this is 2. This one right? They, that's just 1, so it's going to be 2x. And then this one will be 3. Same deal, it's just using the property and the one-to-one property of logarithms to solve. So these are special cases, and if you look for these special patterns, it will make some of your computations easier. Now, on older calculators, whenever you wanted to put in a logarithm with a different base, other than the common log or the natural log, you had to look it up in a table, or you had to use a formula or some other way to handle it. And so what they developed was the change of base formula. And so these are converting log base 2 of 5 point, obviously you're not going to do that one in your head, converting that into something you can put into the calculator. So it's kind of an old-timey thing, but we still look at it. So you would take log base 10, right? I didn't write any base, so we assume it to be log base 10, divided by, and you're going to write the log again of the base. So log 5.738 divided by the log of 2, and you would do that on your calculator and get an answer. This one, the cool thing though, is that you can use either. You can use natural log or log, and you're going to get the same answer. So 5.739 over the natural log of 16, and you'll actually get a decimal number. So that's how you set it up. It's really easy. Most calculators now, especially the fancy Inspires, will just calculate this problem. You don't have to set it up as change of base. But that is another technique that we need to have in our toolkit. Okay, so to evaluate this problem, what you would do is you were given f of x is equal to log to the base 16 of 1/4. Well, remember that you can write 1/4 as a negative exponent, 4 to the negative 1 power. So I'm going to change this to a y just for simplicity's sake. I have log to the base 16 of 4 to the negative 1. I'm going to write it as an exponent. 16 to the y power is equal to 4 to the negative 1 power. Okay, now I need these bases to be the same, and I'm close because 16 is 4 squared. So 4 to the 2y is equal to 4 to the negative 1. The one-to-one property says if these two bases are the same, their exponents have to be equal. So 2y equals negative 1, y equals negative 1/2. So think about that. If I have 16 to the negative 1/2 power, that would be 1 over, right, the square root of 16, which is 4 1/4. Is that true? Okay, then that's it. Here's a special distinction that I want you to notice. I noticed when we were doing exponents, we always had a little bit of trouble with something that had a negative number out in front or a negative exponent. And it's kind of the same thing here. This first one, log to the base 10, the common log of 1 over 1,000 is equal to negative 3. This is true. This is true. Because this number here is an exponent, and exponents can be negative. Okay? Exponents can be negative. If I were to write this as an exponent, I would have 10 to the negative 3, right? Base to an exponent equals a value. Well, I can rewrite 1 over 1,000 to be 10 to the negative 3. So that's a true statement. True statement. So it is possible for an exponent can be 0. So exponents can be negative. They can be negative. On the other hand, if I have something like this, this would be 10, right, base 10, 10 to the x power, that's the exponent, equals negative 2. Now, is there ever going to be an x value that when I put that in there, this value will be negative? Okay, think about it. If I put in all the positive numbers, I'm going to get 10 to that power. So if I put 1, 2, 3, 4, 5, 6, 7, a billion. If I put 10 to a billion, is that going to be negative? No. So what if I put 10 to the negative 1? Well, wait a minute. What is 10 to the negative 1? 10 to the negative 1 just means that's 1/10, positive. It doesn't change its sign. So what I'm saying to you is that a log, you can never take the log of a negative number. So you cannot of a negative number. Now, that goes back to the graph. Remember when we graphed a logarithm? Logarithms look like this. Well, what's true for all of the values, the x values of a log? They're all positive. They're all 0 and positive. There are no logs of negative numbers. So please make this distinction. It's very important. Exponents can be negative, but you cannot take the log of a negative number. It does not exist. All right, so in class, we're going to practice a whole bunch of these. We're going to use our calculator. We're working on skills. We're going to get these down. And so be sure your notes are very complete, and I will see you in class.